Section 4.4 Trigonometric functions at any angle. The first slide you guys don't have it because I didn't want to print an extra slide because I just wanted to keep it at 2 pages double-sided. However, you can recognize from the pictures, they are the 4 seasons of the year, right? So we have spring, summer, fall, and winter. By the way, that's a great idea for like a anniversary picture. Have you guys seen those on Pinterest? You don't know what I'm talking about? Andrew, you know, same place for like the 4 seasons, and then you put them all 4 together. It's great. Okay, so I'm gonna read this quickly. So cycles govern many aspects of life. Heartbeats, you all know that, right? Especially if you have taken anatomy and physiology. There are actually some graphs there, and that's well, I'll talk about that in a minute. Sleep patterns. Seasons and tides all follow regular predictable cycles. Like the tide goes up at night and then it goes down in the morning, right? Yes? Okay. Yes or no?
Yes.
Did you guys know that in Puerto Peñasco is slightly different? In Japan? Mm-hmm.
Japan is yes.
So it does the opposite?
No, like the tide goes way too in.
Okay. All right. So because of their periodic nature, because they just keep repeating, trigonometric functions are used to model this type of phenomena that occur in cycles. It is helpful to apply these models regardless of whether we think of the domains of the trigonometric functions as sets of real numbers or sets of angles. In order to understand and use models for cyclic phenomena from an angle perspective, we need to move beyond right triangles. Okay. So we have covered the unit circle, the right triangle. So now we're going to put those together. And just like I told you before, it doesn't matter if the radius of your circle, like the unit circle, is a 1. Even if it's something different than 1, like in this case, we don't know what it is, but we just call it R. We could also use that. So at this time, what we're going to do is define the 6 trigonometric functions instead of just being back in the unit circle. Sine used to be y over 1, which was just y. Yeah, do you guys remember? And it was because the hypotenuse of the triangle was a 1, because that was the radius of the unit circle. However, now we're moving out of that. And because the triangles will be similar, remember I proved that to you before, the sides, the ratios are proportional. And so instead of saying y over 1, we're going to say y over r. Same thing for cosine. Instead of just saying x, we're going to say x over r. Because r is going to be something different than 1. Okay, so things will change. For tangent, we will still use y over x, because if we divide by using the quotient identity, sine over cosine, and I'm going to keep using these names because I want you guys to remember them, okay? So if we use the y over r and the x over r, and then we divide the fraction over a fraction, you know, you can multiply this outer quantities or variables. So that would be ry. And then here with the inner quantities or variables, it will be rx. So r over r is 1, cancels, so you get y over x. And that's why this one is just the same as it used to be with the unit circle. Now, we already know there's a relationship here, right? How do we call sine and cosecant? They are? Very good. Very good. So just like that, we have cosine to secant and tangent to cotangent. Now, question for a card, so get ready. What is the relationship between these two? And it was from, go ahead, Garrison. Very good. So they are, don't get mad, everyone's going to get a chance. They're co-functions, meaning that they will have the same value for coterminal angles, right? Okay, so Garrison, get a card. You cannot answer again until everyone has answered the question. What is another example of co-functions? Raise your hand. Okay, so Matthew first, and then I'm going to take you for the next question. And so, which one?
Sine and cosine.
Very good. Sine and cosine are also co-functions. And the last one is tangent and cotangent. I won't ask you that because that was the last one, right? And it happens that tangent and cotangent are co-functions, but they're also reciprocals.
Wow.
Yeah.
Awesome.
Okay. So now let's go back over here. Now, you all know we have 4 quadrants, correct? Yes? And so, the 4 quadrants, I want you guys to do the following. So write down sine, cosine, and tangent. Okay, so if the sine is given by y over r, will sine be positive in quadrant 1? The y is positive in quadrant 1, right?
Yes.
Well, first of all, let's acknowledge the quadrants. They go like, I'll write them here. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so sine is positive in quadrant 1, and where else? In quadrant 2. The y is positive. Okay. Now, cosine is x over r. So cosine will be positive in quadrant 1 or negative? Positive, because the x is positive. Where else?
Quadrant 4.
Quadrant 4. Okay, let's finish with sine first. So, actually, okay. Sorry. All right, tangent. Let's do tangent. What do you get if you divide positive over a positive? Positive. All right. Now let's go back to sine. Sine is the y. So y is positive in quadrants 1 and 2. And then in quadrants 3 and 4 is negative. What happens to cosine to the x's in quadrant 2?
Negative.
Negative. And if you divide positive over negative,
Negative.
you get negative. So that means that the tangent will be negative. Now, where else? Well, what about quadrant 3? Is the x positive or negative?
They're both negative.
Negative? No.
Positive, and then you're gonna get.
Now, for tangent, if you divide negative over negative, you get positive. Is the x positive or negative here?
Positive.
Positive. So quadrant 4 is positive. So the tangent is
Negative.
negative. Okay. So that's very useful. Don't ever forget it. We're going to be drawing it again and again. Okay. By the way, how are we going to find r if it's not 1 anymore? So we're going to find it using this formula, which is nothing than the Pythagorean theorem. Instead of c as the square root of a squared plus b squared, we're just changing our variables with r and x and y. All right. So we can have angles, like for example, this angle is less than 90. So the initial side, remember, is always the positive x-axis, and the terminal side is on quadrant 1. The next angle, initial side positive x, terminal side is in quadrant 2. Third angle, initial side positive x, terminal side quadrant 3. And then the last one that we have here, initial side is positive x, and terminal side quadrant 4. So depending where the terminal side is at, that is going to determine if your trigonometric functions will be positive or negative, like that. Okay, that's what we care about, the terminal side. Okay, so now we're going to find the first, the all 6 trigonometric functions given this point right here, okay? And I'm going to tell you what I do not want you to do. Sine of the angle, I don't want you to tell me that it's -5. And it really hurts me when I grade your exams and you do that. Because you're thinking about section 4.2 or 3, right? Where the points used to be given like this. right? So in that case, they were giving you fractions that are less than 1. So that's okay, because the sine and the cosine do not go past 1, positive 1, and negative 1. And so all the values, I'll just graph it here for you. This is what we're going to do next week. The maximum value that you can have for sine is positive 1. And the smallest value you can have for sine is negative 1. So if you were to give me an answer like that, I will think that you're crazy. Because it just can't. It can't happen. So that should tell you, hey, maybe that I'm doing something wrong. So what do we need to do before we stop just using y and x? What is the third variable that we need? Since the radius is no longer 1, we need to find the radius. So we're going to find r. Okay, so that will be x squared, so negative 3 squared, and then negative 5 squared. Now, remember that when you square negative, you're going to get positive, right? Don't mess this up, please. And your first exam, you're not going to use a calculator. Okay? So if you found r and you just wanted to check it, I wouldn't mind. Because if you don't have the correct r, all the 6 trigonometric functions will be wrong. Okay? We don't want to do that. Okay, so this will be 9 plus 25. So it's 30. No, 34. You almost got it. Okay, so the square root of 34 cannot be simplified any further, so we'll just leave it like that. And so sine is going to be negative 5 over the square root of 34. Then I have to rationalize, right? So we multiply by the square root of 34, we get negative 5 square root of 34 over 34, very good. Okay, now the cosine, we're going to have x over r, so that would be negative 3 over the square root of 34. Rationalize, so that would be negative 3 square root of 34 over 34. And then tangent. So tangent is going to be y over x from here. So negative 5 over negative 3, and that becomes 5 over 3 positive. Very good. Oh, I forgot a C. A lot of room. Okay, so who's gonna tell me cosecant? Oh, Andrew, you were next. You want to tell me cosecant?
That would be negative square root of 34 over 5.
Very nice. And so you gave me the reciprocal of this one. Nice. Who's gonna tell me secant, Julio?
Negative 34 with the thing
With the thing, with the square root over 3. Very good. Who's going to give me cotangent? Chris?
Oh.
That's too easy for you, Andrew.
Yeah. You're trying hard.
3 over 5? Yeah, it's that easy. Don't be surprised. It's that easy. Trig is beautiful. Okay, so I want you guys, you're going to find all of those, and then you have an opportunity to answer from a card. What I'm going to suggest you do all the time, just plot the point so you can get a good idea of where the terminal side will be at. So positive 1, negative 3, that's the terminal side, the coordinates of the terminal side. So that means that this angle is starting here in standard position, positive x-axis goes all the way here, and then the terminal side stops here. It's a pattern. Okay. So remember, first you need to find r. Okay, so I got the square root of 10. You cannot simplify it, so that's what we're going to use for R. Okay, so Julio, since you already answered, do you mind writing them for me? You can write for me on the board, because I'm gonna be walking around giving cards. So,
You never give us all that?
I didn't give you a card. No, you don't need to. You will be my secretary, kind of.
You just pass?
Yes,
Do I get the double card?
yes, you got one for voluntary.
Oh.
There you go.
I would have volunteered.
Because it's nice to volunteer now. Teachers' pet get a lot of privileges, even in college. It's real. Okay, so who's gonna tell me? Okay, Andrew, what is the sign of theta?
-3 square root of 10 over 10.
Okay, so let's do this.
-3 square root of 2 square root of 10 square root of 10 over 10.
Can I say cosine, miss?
Okay, wait a second. So, if you guys give me the rationalized form, let's do this, Julio. Let me show my assistant. So you say -3 square root of 10 over 10. Okay, so then before he rationalized, what was it? Andrew?
Oh, I don't.
-3 over square root of 10.
Over the square root of 10. Okay. So you guys, I want you to give me both, before and after you rationalize. All right. Okay, Carlos, go ahead. You'll get a chance, don't worry.
So the first one is 1 over square root of 10. And then after it's square root of 10 over 10.
Very good. Okay. Jen. Okay, Andrea.
Oh,
Over. And that equals? Very good. Very good.
Can I hear cosine?
What? Why?
All right, next one, Regina. Oh, you don't have that one? Okay. You got it, Jerry?
Ow.
Cosecant? Okay.
Square root of 10 over 3, over -3.
Very good.
I didn't think about that. What?
Negative?
-3.
Now, would it be okay if we put the negative on top?
It doesn't matter.
It doesn't matter, but what matters? What will make it wrong?
That one.
To have it in both, like two negatives, to have a double negative. That would be wrong. Okay.
You can answer.
You cannot answer. Sorry, sir. You're out of the game. Okay. Oh my gosh, you cannot answer either. Okay, Jerry, then you go, Edwin. Jeremy, sorry. Second. Oh my God.
It's negative. It's negative. It's square root of 10 over 1, and then it comes down.
Square root of 10. Very good.
I mean,
Very
square
good. Okay, Edwin. You're gonna give us the last one.
-1 over 3.
Very good.
Hey, I should have done that.
Good job, guys. That was great. Great work. Okay, so if you don't have a card, your time's coming. Yeah.
We have a pair.
Okay, the next thing we're gonna do is we need to find the sine, the tangent, and then down here we have to find the cosine and the cosecant. So I don't want to do them in that order. Instead, I want to find sine and cosine first. Oh, also, by the way, these are called the quadrantal angles. And those are the angles that, for which its terminal side is on the x or y axis. So 90, pi over 2, 180, which is equivalent to pi, 270, which is 3 pi over 2. Okay, so I want you guys to draw let's draw the unit circle. We all know it. So what are the coordinates here at this point? If it's a unit circle, the x, 1, 0. How about this point here?
0, 1.
0, 1.
Next point.
1,
Negative 1, 0. 0,
0, negative 1.
0.
Okay, and okay, let's just make sure we know where the radians are. So this is 0, this is pi over 2, or 90, this is pi, or 180, and of course this is 3 pi over 2. So those are the quadrantal angles, yes? Don't forget that. All right, so we're going to write the following. Sine, well, I need a little more space. Just look here the symbol theta, and then we'll write 0, 90, or pi over 2, 180, or pi, and then 270, or 3 pi over 2. Okay, so remember that the points will tell you the cosine of theta and then the sine of theta. Okay?
Yes.
So, if you do not have a card, you can answer. Only if you do not have a card. Okay. So what is the sine of 0? Raise your hand. You already answered, Anthony?
0.
Very good.
Ooh.
All we have to do is look at this number right here. That's it. What is the sine of pi over 2? Julissa? Very good. What is, oh, I haven't even, okay, Regina, you go next. What is the sine of 180? 0. So she's looking at the what? Okay, what is the sine of 3 pi over 2? Chris, you already answered one, no? Yeah. Oh, well, then you gotta remind me. Okay, who else answered and I didn't give the card, Anthony? All right, Yvette, and then I'll take you, Anna. So at 3 pi over 2, negative 1, very good. Okay, Anna, what is the cosine of 0? Very good.
Negative 0.
Okay, Trisha, cosine of pi over 2? Okay. Who has an answer? Chris. Cosine of pi?
Negative 1.
Very good. And who doesn't have a card? Okay. Catherine, cosine of 3 pi over 2? 0. Very good. Great job. Oh, wait. Card.
Yeah.
Card. And card. Okay, now for the next one. You guys gotta remind me. Okay, now for this one, we're going to find the other two that we were asked, which are tangent and cosecant. Very good.
Wait.
The cosecant and the tangent.
No, it's cosine and cosecant is
Yeah,
what
it's
that's for.
cosine.
No, but we're.
We already found cosine.
Yeah.
I changed the order.
What's okay?
Wow.
I wouldn't give him any more cards if that other two.
Ooh. Fire.
You reminds me of myself. That's why I put up with it.
Huh?
It's my karma.
It's your karma?
Yes.
I hear karma.
Okay, so I'm gonna give you guys a few minutes. You can work with your partners. Remember that to get tangent, you need to divide sine over cosine. And to get cosecant, you need the reciprocal of sine. And for this one, divide sine over cosine. Yeah, you guys, a few minutes. Who still has not answered question? Oh, Mateo. Janet, come on. Jamie. Taylor.
Yes.
You three. Once you three answer a question, everyone can answer again.
Is that really everyone?
Yes. What else? I'm considering adding another day.
90s
Yeah.
undefined, right?
I think this one.
Yeah, because then you just We're too fast. That's their talent.
Yeah.
Okay, guys, are we ready for this?
Yes, yes.
Okay. They have to answer first. Okay, so Mateo, you ready? Okay, tangent of 0. Come on, Mateo, tangent of 0.
0.
Very good. Because 0 over 1 is
0.
0. Okay, tangent of pi over 2, Taylor.
Isn't it undefined?
Very good. Because 1 over 0, undefined. Very good. And then we need Jamie. Tangent of pi. Yes, very good. Because 0 over -1 is 0.
Can we answer that?
Yes, now you're going to wait. I'm going to ask them in different order. I'm going to ask them in random order. Okay. I have to be here. So the first one to raise their hand. Because now we're going to have to take out the buffers. Because you guys get too late.
I don't like that.
Okay. What is the cosecant of pi?
Oh, I can do that one.
All right. I saw Julio first.
Julio was.
He didn't even know.
Cosecant of pi.
Undefined.
That is true.
Yeah.
Because the sign is 0. Very good. Okay. What is the tangent of 3 pi over 2? Okay, Andrea was first.
What the fuck is it? No. I'm here. No, I didn't.
Yes.
Wait, what are you saying?
Gosh, Andrew.
What do you mean, gosh, me? Look.
What was it? Sorry. Tangent of negative.
Undefined.
Undefined because we will divide by 0. Okay. What is the cosecant of pi over 2? Okay, it was Andrew. What is it, Andrew?
It's 0. Yes, it is.
That's wrong.
No, that's right.
That's wrong! What is it, Gerson?
1.
That's correct.
No.
So, remember, it's the inverse. I'm sorry, the reciprocal of 1. Okay, cosecant of 0. This is too hard. Okay, it's really accepted. Cosecant of 0 undefined. Very
I
good.
don't even wanna.
Because
I don't
sine
even
is
wanna-
0. All right, Carlo, you go next.
No, I don't know that one.
Oh.
Wait, miss.
1.
Negative 1. Negative 1. Negative 1.
No one gets it.
You said it's 0. It's negative 1. 0, 0, 0, 0.
No one gets it.
No one gets that one. You cannot shout the answer until you're verbally recognized. Like in science book.
What is it, miss?
Well, did not get a card that
He's lying.
Yeah, he took off.
I don't know. I'm just kidding. Okay, well, it's now -1, right?
Yes.
Because the reciprocal of this is still -1. Okay, what time is it? Oh, we still have a lot of time. Okay, perfect. Yeah. Okay, the next slide, example 3. I'm talking, so you have to actually find where the terminal side of the angle will, the quadrant of that terminal side. So we're gonna use the information given here and here. So first, let's just practice how to construct our little symbol helper, I guess. Okay, so the y is positive in quadrants 1 and 2. And it's negative in quadrants 3 and 4. The x is positive in quadrants 1 and 4. And the x is negative in quadrants 2 and 3. So then for tangent, we divide. So positive or positive? Positive or negative?
Negative.
Positive.
Positive.
Okay, if you all are saying things, you're gonna ruin my video. Okay, so negative divided by negative is?
Awesome.
Thank you. Negative divided by positive? Negative. Yes, you guys have to reply at the same time. Okay, so now let's see what they're asking us to do. The tangent is negative. Where's the tangent negative? In quadrants?
2 and
2, 4.
Okay. But where, out of those two, where is the cosine positive?
4.
Only 4. So that's the one we need. Yes? Are we clear on that? So that means that we're going to have some angle that will go from here somewhere over here. Okay? Let's do the next one. So go ahead and construct your little symbol helper. So positive, positive, negative, negative, positive, positive, negative, negative, positive, positive, negative.
Wait, that's less than.
Yes.
It's in the third.
That's in the third one.
What's in the third one? Oh, like you're giving me the answer. Oh. You're too fast for me. Okay, so sine is negative here and here. And then the cosine is negative only in the third quadrant out of those two. Okay, so Regina deserves a card. So this is negative. This is negative. Remember what less than 0 is negative, greater than 0 is positive. Yo. Okay, are we clear why we're talking about quadrant 3? So it will be some type of angle like that. And this was quadrant 4. Okay, let's move on to the next problem. So we're going to first identify where this thing will be, okay? The angle, the terminal side of the angle. So we know that the tangent is only positive in quadrants 1 and 3. Yeah, do we agree? Positive, positive. And then the cosine is positive only. The x is positive in quadrants 1 and 4. So it's this one. So the tangent is positive and the cosine is positive. I'm sorry, this is a big negative. I'm so wrong.
Yeah.
Okay, so erase everything I said from your mind. Okay, I'm just gonna write them again. So like positive, 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 negative, negative, positive, negative, 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 positive, negative. Okay. So the tangent is negative here and here. And then the cosine is positive
Quadrant 4.
quadrant 4. So that's the one we need. Okay, and we need to find the cosine. And we have to find cosecant as well.
Miss, I know it.
Okay, just wait until I ask you. Okay, so
Do you have
Okay, so, what is there that tangent tells us? Tangent will tell me the y over x, correct?
Yes.
So that's telling me, if we're talking about quadrant 4, which one will carry the negative sign, the y or the x?
The one.
The white.
The y. So the y is -2, and the x is 3. Now, can I say that cosine is 3?
No.
No, because cosine can only go from -1 to 1.
Oh, yeah, yeah.
If you go past 1, you're crazy. Okay, that's like a big no. Remember the wave? It only goes from +1 to -1. That's why we call it the unit circle. The wave, and that's what we're going to do next week, is nothing but the unit circle, like, unwinded. Oh, and by the way, today is nice outside, so we're going to do the carousel.
Yay.
I don't care if you're not wearing tennis shoes. Most of you are. That's okay.
Everyone
We'll put you close to the center.
I like the testing.
So what is it that we need to find before we start doing all the answering the question? The units, the radius is not 1 anymore. What is it?
always depend on the R.
We have to find r. So r will be the square root of 3 squared plus -2 squared. So that would be what? 9 plus 4. So that's the square root of 13. Okay. So then for cosine, that would be 4 card. Cosine of theta, what is it?
2 square root of 13 over 13. Is it?
I think so. Let me see. It's because I cannot rationalize in my head. I have to do it the long way. So that would be x. That's a 3. Oh, you said 2. It's a 3.
Oh, 3 square root of 13 over 13.
I got it.
Miss, I said 3 though. I said 3 square root of 13 over 13.
I feel like arguing. 3 square root of 13 over 13. Okay, here you go. You got 2 cards.
Oh, because you put the X?
The whole day? Or to like everyone else answers?
Yeah, but I'm almost out of cards. Okay, now who's gonna tell me the cosecant? So that's gonna be the r over y. Yes, whatever.
Square root of 13 over 8.
Wait.
No. It's,
Go, no, he's right.
no, he's not.
Yes.
I think
Cosecant is r over y. So what is r? Square root of 13 over
2, -2, not 3.
You know what? You don't need that now.
the
I'm not
y.
yelling at you. My point. So give me my card.
I thought you.
it's over 3.
No, it's -2.
Oh, it's -2.
Yes, it is.
And what did you say?
He said 3.
He said negative.
Okay, I'm just gonna give him the card. You go next. I trust. Andrew goes next, okay? No one can answer by Andrew. Ay, Mateo. Mateo.
Unfair. This is worse than Russia.
Andrew's gonna be the last one. Hold on, guys.
Possibility.
Okay, so we're talking about something where the tangent happens to be negative. So that could occur in quadrants 2 or 4, correct? And they're telling us that the cosine is positive. So that could only occur in quadrants 1 and 4. So the one where both occur will be quadrant 4, correct? So then if we go in this direction, what is going to be negative, the x or the y? Okay, so then -1 over 3. So if I want to say cotangent, that would be the reciprocal of it, so it's going to be -3 over 1, so that's -3. And then here for sine of theta, we need to find r still. So r is going to be the square root of -1 squared plus 3 squared. So that's going to be 1 plus 9, which will be the square root of 10. That cannot be reduced. So then sine is going to be x is positive 3, right? And y is negative 1, and r is the square root of 10. Okay, so sine will be negative 1 over the square root of 10, so that will be negative square root of 10 over 10. Cosine is going to be positive 3 over the square root of 10, so that turns into 3 square root of 10 over 10. We have cosecant, which is the reciprocal sign.
Or negative.
So square root of 10 over negative 1, or just negative square root of 10. Then we have secant, which is the reciprocal of cosine, and so that's going to be square root of 10 over 3. Okay, great. So go to your break, and then we're going to do that activity exercise. If you want to turn on your laptop before you go out, that would be great. So let's continue here with reference angles. Please copy the definition. I'm going to explain it. So we have, first of all, we have an angle that is non-acute. So what does that mean? It could be anything but acute. So this one here is obtuse, right? And then we have here one that is more than 180. And then we have one here that is more than 370. So all those three are examples of a non-acute. Yes? Are we okay with that part? So now the reference angle, is going to be the angle that is formed with the first original angle's terminal side, the terminal side of the original angle, and with the x-axis. So for the first example, our reference angle will go from here to here. And here is what we call reference. So let me give you an example. If theta was, for example, 135 degrees, what do you guys think this will be? The reference angle, which I'm going to call theta prime. So you know that the whole thing complete is what? 180. So if we say 180 minus 135, we will get that it is 45. That's the reference angle. So reference angles, they will always be positive and they will always be acute. Don't forget that. Okay, the next one, let me give you an example that kind of works with it. Okay, so if theta is equal to 240, what will theta prime be? Theta prime is this one right here. 30. Actually, this one will be 30.
Yeah.
But we want that with the x-axis. So it's a little bit over 180, right? So if we say 240 minus 180, we'll get 60. And that's what it is. So let me ask you a question. When you know what a clock is, right? Yes, like that one. So what will this time be?
Or 12:45.
12:45. What? How can I say 12:45 without saying 12? Without using 12?
15.
15 para las 1 or a quarter until 1. Right? So that one is actually past, like a quarter past. The one before it will be a little bit until 360. Right? So this will be more like an example of a clock, like you have 12 and then 15, something like that. So that would be like a quarter past 12. So here we went 60 degrees past pi or 180. So that's why we say 240 minus 180. And the formula is actually here. Okay, the very last one if I tell you theta is, let me just tell you what it is. 330. Find theta prime. Don't say it out loud. Miss Ben? Oh, yes, of course. I'll send him to the office. Miss Alonso, okay, I'll send him right away. You're welcome. Matthew, so let me finish this and then you can go. All right, so if this is 330, theta prime is almost, I'm sorry, this angle is almost at 360, right? It's just missing a little 30. Yeah, there you go. So that could be found by 360 minus theta. So those are reference angles. Do not confuse them with coterminal. They're different, okay? Okay. So let's find examples here. So for 345, theta prime will be 360 minus 345. So the reference angle will be 15. Yes, go ahead, Matthew. So I have here 345 right there. Just watch the last part, okay?
Okay.
And good luck. I think you're going to do great. And then here, this reference is 15. Okay, next problem. We have 5 pi over 6. 5 pi over 6, is that going to be before or after pi?
Before.
Before pi. And so if we know that pi is equal to 6 pi over 6, we're almost there. We're short by pi over 6. Very good. Like a quarter until 1. We're like pi over 6 until pi. Something like that. So numerically, you will say pi minus 5 pi over 6. And that's how you get your pi over 6. Because the pi is 6 pi over 6. Okay, part C. We have a negative angle and it's 135. So will that be, if I start here in standard position, remember, and then I'm going the negative direction, so it goes clockwise. So here I have negative 90. And then what else do I need? Another 45. So then how much do I have left to go to that negative 180? 45.
Negative 40.
Now, that's a great question. Would it be negative or positive? Well, reference angles are always positive. So we will say positive 45. Okay? All right, now for part D, that is in radians. So here's pi. What is pi approximately? 3.4. Okay. And then what is pi over 2? Like if you divide pi over 2, it's going to be like
1.07.
No, it's 57. 1.57. So the 2.5 is going to be like somewhere in between, right? So we start here, and then it will be somewhere over here. Okay. So now to find my reference angle, I should say pi minus 2.5. Can someone give me that number? Please. Oh, I have it here. I don't know. What example is that? 5.
0.64.
0.64. 0.64. Okay, great. Now, can we find reference angles of angles that are bigger than 360? Yes, definitely. So here we have a 580. So first of all, we'll have to subtract 360. Yes. So 0, 2, 220. Okay. So I'm going to draw it. To me, drawing the angle works better. Then I know exactly the quadrants and everything. Smartboard.
Maybe give it a marker.
Okay, that's better, that's better. Okay, so I'm gonna draw that angle 580. So we already know we have to go a complete turn, that's 360. And then what else do I need? 220. So right here I have 180. And then what else do I need?
220.
So here 220 minus 180. What is it? Another 40. So right there. So you already know what the reference angle is, right? Because we got it from here. This one right here is 40. That's why I like drawing them. It kind of tells me what to do. If I don't draw them, I'm not very good. Just like, do I subtract or what? Okay, part B. That one is also bigger than 2 pi. Because what is 2 pi in thirds? 6 pi over 3. So is 8 pi over 3 bigger? Yes. So we go here, full turn, and then what else do I need?
2 pi over 3.
So this one, it will be a complete turn, and then an extra 2 pi over 3. Look over there on the board, the last circle, where's 2 pi over 3?
Past 90.
Past 90. Right there. So there's our angle.
So the reference angle would just be 2 pi over 3?
I don't think so. Because the 2 pi over 3 is from here to here.
Okay.
Okay? But think about it. What is it from here to here?
Oh.
Pi, or 3 pi over 3.
So it'd be pi over 3.
So you will find that it will be pi over 3, yes. You will find it by saying pi minus the little extra that we did after the complete turn. So it's pi over 3. Okay, and then the third one here. We have a negative angle at 13 pi over 6. So is it past a full turn? Yes, absolutely. In the negative direction, by the way.
And then you do one more turn.
Because negative 12 pi over 6 is negative 2 pi. And then we do how much more, Andrew?
Oh, one more?
It's like one.
Oh, no.
Like a little tiny bit
yeah.
more. Like an extra
1/6 of a pi.
1/6 of a pi. So right there. Okay, so that little extra that we went past, that's actually going to be a reference angle. Because remember, but with a negative or positive?
Positive.
Always positive. So right here, the reference angle is positive pi over 6. Okay. Let's hurry up and do this. Okay, so let's do the following. Let's find first the reference angle of tangent. Of 120, sorry. So 120 is going to be like before I get to 180, right? How far before I get to 180? Yes. So my reference angle here is 60. Because it's 60 degrees until 180. Like the clock. Okay, so because of that, could you guys tell me what is the sign of 60 by any chance? No. Okay, I'll tell you one. The sign of 30 is 1/2. So the sign of 30 is 1/2. The sign of 60 is the other one with our root.
What?
3. Square root of 3 over 2. Good job, Carlo. Was that Carlo or Jerry? Okay. So, or Jerry. I'm just kidding. Okay, Jerry. Okay, so that's square root of 3 over 2. What is the cosine of 60? Well, if it's not that one, it's the other one, right?
Yeah.
1/2. Now, what is the tangent? If you divide those two, you get tangent, correct? Of 60?
Negative, I mean, square root of
So the 2's cancel, and then it will be just the square root of 3. Very good. So because the tangent of the reference angle is the square root of 3, the tangent of 120 is also going to be the square root of 3. There's just one little change. Should it be positive or negative? Let's remember. Positive, positive, negative, negative, positive, positive, negative, negative,
negative.
positive, positive, negative, negative. So 120 is there, so it should be negative. So that's what reference angles are good. And you just have to learn the first, like the special ones, like 30, 45, 60, 90, or the quadrantal ones. And with that, you can find anything else. So for example, here for sine of 135, if I draw that angle, I'm going to draw that angle, so it's going to be before 180, right? How far before 180? A little bit. What is that little bit going to be? Which one?
45 degrees.
45 degrees. So what is the sine of 45? That's the very easy one. The one that a cosine and sine are the same.
Square root of 2 over 2.
Mhm.
And square root of 2 over 2 for cosine of 45. And then tangent would be.
So what will be the one for this one?
What?
What is the sine of 135?
Oh, positive.
Square root of 2 over 2. Should we keep it positive or negative?
Positive.
Positive because the terminal side is in quadrant 2 and the y's are positive here. Okay, the next one is cosine. So we're going to go past 3 pi over 3, which is pi. And then we're going to go another pi over 3 after. So that little extra pi over 3, that right there, guys, is our reference angle. So what is the cosine at pi over 3? I remind you that pi over 3 is the same as 60. We have it up there. The cosine of 60 is 1/2. So what is the cosine of 4 pi over 3? It's also going to be 1/2, but is it going to be positive or negative? Because the x's are negative here, so we need a negative sign. Okay, the last one is cotangent. Negative pi over 3, so we go in the negative direction, pi over 3, it's right there. So our reference angle is just simply going to be positive pi over 3. Why? Because reference angles are always positive. So if you know what is the cotangent of pi over 3, let's see. So if you guys notice, we have everything we need because cotangent happens to be the cosine over the sine, the reciprocal of tangent. So this will be the cosine of pi over 3 is right here, 1/2. And the sine of pi over 3 is the square root of 3 over 2. Cancel the 2's, and we get 1 over square root of 3, but we don't need it like
So
that.
square root of 3 over 3.
Very good. After rationalizing, right? Okay, so if the cotangent of pi over 3 is the square root of 3 over 3, what would it be in this quadrant?
Negative.
Positive or negative?
Negative.
So remember, here the x is positive, but the y is negative. What happens when you divide one of each? You get negative. So this will be negative square root of 3 over 3. Classic. Okay, and then those two I just don't want to do them. I'm tired. Okay, and then the last slide is a little treat for you, my gift. Everything that we cover is summarized here. Now feel free to use that as a reference. Don't get too used to the calculator because when you take your first exam, you will not use the calculator. Nope. All that needs to be in your head. No, not in your head.
On your arm.
Aw.
You still have to.
Yay, we're done.